Good morning, everyone. I'm Dr. Kumar from Danan Sakar College of Engineering, Automobile Engineering. Today we will see how to calculate the brake force in an hydraulic braking system. An hydraulic braking system can be drawn in this way. So now what I have drawn now looks like a system for a brake for a bike. So it is the brake lever. It is the brake lever. And now this brake lever operates a piston which actually pushes the hydraulic fluid here. So this system is called as the master cylinder, which actually pressurizes the hydraulic fluid, and that hydraulic pressure is sent into what is called as the wheel cylinder. So the wheel cylinder has a piston here which actually pushes the brake pads, and that applies force on the brake disc, and the brake disc is held. And finally the application of the force on the brake disc, which is in this direction, has to be converted into a force tangentially. So force tangentially, and finally it should be related to the brake force at the wheel, the brake force at the wheel. So we want to derive this brake force, which you call it as FB, or people simply call it as F. Okay? So for that, we should start from where the force is being applied. So the force is being applied maybe on the lever like this. So you can call it as the pedal force or lever force, or whatever you want to write it as. So usually when you do it, so let us have like this distance through which you are applying the force, maybe around 3x times or 5x times, and this distance is actually x times. So that means you can see that now whatever the force that you applied here, it becomes 5 times FP, because you got a leverage here. So once you got this force which is being applied, that force now converts as pressure, it goes here, and suppose if it is of the same area of the piston here, then you will have the same force here, but you will definitely have different areas here. So let us call that the area of this piston or this bore to be AM. AM stands for area of the master cylinder. And the same fluid comes here and it comes to this point, and this piston or the bore will have an area which is called as AW. AW stands for wheel cylinder. So here, if this area is larger, then it is beneficial and it will actually magnify force. If it is smaller than this, then the force gets reduced. So we can say that the 5P which is here, it again increases by the ratio of AW by AM. So I can say that now the force, the brake force FB is proportional to 5P. Sorry, I can say that it is proportional to the pedal force multiplied by this phi. This phi can be called as the magnification, the mechanical magnification, which we call it as RP, ratio of pedal. So the first thing that you see is the mechanical magnification. Then the second thing that you see is the hydraulic magnification. So that is the ratio of AW divided by AM. And then that force gets magnified here now by this ratio. So you can almost say that with this you can almost find out the force at this point, which is actually the force at the, it is not the force at the brake, so you can call this as the force at the, you can say that the brake pads here. It is the force of the brake pad here. So once you have got the force of the brake pad, then you can actually definitely calculate the brake force which is generated tangential to this. So first let us now look at this and go to the next equation. Okay, now once you have got this brake force, then we can actually, that force is applied normal to this board, and if you want a tangential force here, suppose if the wheel is rotating like this, then the brake force will be opposite direction. So that brake force at the pedal, so or maybe you can say that at the piston, the brake pads will be is equal to mu into N, where N is the normal force, but here you know that this is actually N, because the normal force acting on the brake pad, brake disc is actually this. So this becomes now this force is actually mu into this force, which is actually the pedal force multiplied by the mechanical magnification multiplied by the hydraulic magnification, AW by AM. And here you have to multiply by one more term here, which we have forgotten. So that is, here you have two brake pads here. Since you have got two brake pads here, there are two friction surfaces. So you have to multiply by the number of friction surfaces. Number of friction surfaces, F. So I think this F word is confusing. So can you give some name for this? Friction surfaces. So usually it is 2. Usually for most of this is 2. The friction surfaces are 2. So therefore we write it as 2. Okay. So this is actually Fs. So I am multiplying by this Fs, which is actually the friction surfaces. Then the number of friction surfaces here. The number of friction surfaces. This gives the force which is actually trying to slow down the vehicle by actually applying a force in the opposite direction. But you know that the tire, so this actually will give you the braking torque because this force multiplied by this R. So that is the one which is actually trying to slow down the vehicle. So you can say that braking torque is actually equal to FBP, that is the brake force at the pads multiplied by this small r. But the one which is actually finally applied on the wheel, the brake force at the wheel, or simply you can call it as the brake force. So that is actually applied here. So you can say that that brake force is equal to the force which is applied on the wheel multiplied by r, because this force is being applied at this point and the radius is r, and this brake force is at the wheel here. So FB into R. So finally you can say that if you want this, suppose if you want the brake force FW, then FW is equal to FBP multiplied by R divided by small r. But you already know that FBP is already written here like this. Okay. FBP at the piston, you can call it as piston here. You can substitute here. So finally you have an equation here. Finally the brake force FW is equal to FBP, which is actually mu into FP multiplied by RP multiplied by hydraulic magnification. So the earlier one is mechanical magnification into number of surfaces multiplied by small r by capital R. So this is the equation for the brake force which is generated at the wheel. So using this brake force at the wheel, you can definitely calculate the braking distance. The braking distance, you know, is if you know that if a vehicle is going at some speed like 108 kilometer, maybe around 36 kilometers per hour. Then if you know that the velocity of the vehicle is 36 kilometers per hour, then this is actually equal to 10 meters per second of velocity, and we can say that the kinetic energy is equal to half mv square. Suppose the weight of the vehicle is around, suppose if it is a bike which is around 250 kgs along with the rider, then the equation becomes half into mass of the vehicle, that is 250 kgs, into this velocity square, that is 10 meter per second whole square. So can you tell me what is the value here? So 100 square, I mean this is 100, so this is 125, so 125, here 2 more zeros, this becomes kg meter per second square into meter. So finally this is actually 12.5 kilonewtons, so kilonewton meter. So this is actually kilowatt, so 12.5 kilowatts here, because you know that Newton meter is nothing but watt. So this much amount of work is actually consumed, has to be consumed during braking. So here if you want, suppose if you can find out the braking distance here, if you can find out the braking distance here, then this is the energy which has to be absorbed. That energy which has to be absorbed can be equated as kinetic energy is equal to the brake force Fw multiplied by the braking distance. So in this way, so right now I have got the braking force, the kinetic energy, which is actually 12500 Newton meter is equal to Fw. Suppose now here let us say that in a bike, what is the force that you applied in a, what is the force that you will apply in a bike with your fingers? Is it actually 1 kg or 2 kg or what? I think you know that when you are lifting a 5 kg weight, maybe in your, suppose if you are carrying a polythene cover of 5 kgs, you actually hold it in your finger, no? You feel the force. That force you are literally applying here. So will the force on the brake lever be equal to around 2 kgs or 3 kgs? Suppose let us say it is around 3 kgs. So let us say this is around 3 kgs. Fp will be around 3 kgs. So 3 kgs is approximately is equal to 30 newtons. So this is actually 30 newtons. Because 3 kg force is 30 newtons. And you know that mu is the friction between the brake pads, which is usually around 0.6. Which is usually around 0.6. And here this Rp. So Rp stands for what? The pedal ratio, which is the mechanical magnification. It can be around 5 times. Okay. Multiplied by the area of the wheel cylinder. Divided by the area of the master cylinder. So usually the wheel cylinders are larger, and you know, suppose if the diameter increases by 2 times, the area increases by 4 times. Suppose if the diameter here is 4 times, then the area, the diameter of this, so that means the area is 16 times more. So you can say that this AW by AM ratio can be almost 16 times. So I am taking some value, a random value which could be actually guessed in this. And then Fs. What does this Fs stand for? So that is the number of friction surfaces. The number of friction surfaces are 2 here. And here, let us say now, suppose the wheel is around, so let us say now without much complications, let us say that the brake disc is around 250 mm. This is around 250 mm. And this wheel is around 400 mm. Okay, 400 mm. So here you get this Fw. So can you actually guess what would be the value of Fw? Here all these are ratios. Here you can see, here only there is newtons. Here millimeter gets cancelled. Here it is number. Here it is again a ratio of area. Here it is again a ratio. Rp is actually the pedal ratio. All these are ratios. So finally the answer that you get will be in newtons. Can somebody give me the answer here in terms of newtons? 1800. You got the answer of around 1800 newtons of force which is being applied here. Okay. Now let us see, suppose if this is a bike of around 250 kgs and you are going at 36 km per hour, according to this calculation, what would be the braking distance? Okay, now 1800 newtons is the force. So let us say that finally the friction, the braking force at the wheel is around 1800 newtons. 1800 newtons multiplied by the braking distance. So braking distance has to be in meters because here it is in meters. So here braking distance BD is equal to 12500 Newton meter divided by 1800 newtons. So can you tell me so much it will be?
6.94.
6.94
meter.
No man, I think it's just only that. Is it the right value? So these two zeros cancel. So it is 6.94 meters. So Here it is giving, okay, is it a meaningful value? 6.94 meters. 6.94 meters means from here to there. Do you need so much of distance to break? Do you need so much of distance to break? Okay, 6.94 meters is the almost the width of our classroom. So going at 36 km per hour, if you hold with a force of around what is the force that we gave here? Which kgs ಕೊಟ್ಟಿರೋದು? So FP, which is actually 5 kg ಇಲ್ಲ 3 kgs ಕೊಟ್ಟಿರೋದು. So 3 kgs force ಹಾಕಿದ್ರೆ 13 newtons. So 13 newtons 3 kg force ಇದ್ರ ಮೇಲೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ you will get a stopping distance of 6.94. Suppose if you apply more force, suppose if you double the force here, ನೀವು ಈಗ 3 kgs ಹಾಕೋದ್ ಬದಲು if you apply 6 kgs of force, definitely this value will be half of it. Okay, like this. If you want faster braking, you will apply more force with your finger. Okay, so or otherwise whatever the values that you have taken, maybe slightly tweaked so that you can get a better braking distance. So this is the way the braking distance is calculated.